Hi everyone, so today we are going to be talking about bias and variance, overfitting and underfitting. So if you have been learning deep learning or machine learning for a while, you may have come across these terms. And this is one of the most important concepts which you need to learn, and almost all deep learning practitioners have a really good knowledge of these two concepts. And this is one of the concepts which is easier to learn but almost very difficult to implement. And so let's say if you have a training set like this, so over here I've shown three graphs, and if you try to plot it, and over here as you can see, this is just example of binary classification, and I have two different training sets plotted over here. And if I train my neural network and my neural network comes with a decision boundary, as you can see it's linear, and I said our model is said to be suffering from high bias because our model is not able to classify or differentiate the two different training sets properly. And over here the line is totally, this decision boundary is totally linear, and the differentiation part is done properly, and we say that our model is said to be suffering from underfitting. Now let's talk about high variance. So what's high variance? So if you try to plot training sets and your decision boundary is too complex, that if you try to visualize, if you put more training set into it, your model is not going to do very well, because the decision boundary is too complex in this case, that if you are going to add more training data, it will not be able to set or fit properly. And you said your model is said to be suffering from overfitting, or called high variance. And earlier people used to suffer from bias variance trade-off, but I think in deep learning era we have come with really good methods which try to reduce overfitting, and I'll make a video, check it out, that in which we'll talk about how you can reduce overfitting. And one of the best things which you can do to ensure that you don't suffer from overfitting is, you should really ensure that your data distribution come from the same source. Your training data and your test data or def set should come from the same distribution. Otherwise it would be difficult for your neural network to come up with this. This is called the just right condition, in which the distinguish part is being done properly. And as you can see, this type of classification just really helps us, your neural network to come up with a solution which really does very well. So this is called just fit, and this is a condition which lies in the middle between your model being suffering from underfitting or overfitting. So statistically, if you try to visualize it, you're gonna see a graph like this. This is a graph of overfitting, and as you can see, our neural network has come up with a complex decision boundary, that it is too difficult for us to come up with a new decision boundary which really fits if we are going to put more training set into it. In underfitting, generally you're going to see more of a linear hypothesis, and this is because your model is not able to distinguish the two different parts. So just let's say it's 1 or it's 0, and the model is not able to classify properly. And in overfitting, your model is going to perform very well on the existing training set, but on the validation accuracy set you are not going to do really well, and you're going to have to change it. And let's take an example of cat dog. So if your model predicts cat, then we say, let's say y is equal to 1, and if it's a dog, let's y is equal to 0. And on a training set error, if it's too low, very low, you say like your model is suffering from high variance. If they are very close to each other, you say your model is suffering from high variance, in which you get more of a linear hypothesis. And if the difference is too large and if depth set error is high, you say that your model is suffering from high bias and high variance. And we're going to talk about this in the next slide. And then if both are very low, you say that the model is suffering from low bias, no variance. And it's very essential for us to come up with a model which does not overfit and underfit really. And the best part is to prevent both of them is intuition, and it comes up with a hell lot of a practice of hyperparameters and learning rates, which we are going to talk about later. So if you were to visualize this is the graph which looks like model is suffering from high bias and high variance. And on the one side, your model is fitting the data just right, but on the other hand, it's overfitting too much. And this is the worst of all the conditions which your model can come across. So for more visualization part, I've put this graph as well, and here you can see inappropriately overfitting. We are not 100% sure that the model is going to predict the output correctly. If you are going to use softmax regression in the last layer, let's take an example of convolutional neural networks, our model may not perform perfectly, but if it's close to 95%, we assume that we are doing really well, and it's better than underfitting and overfitting. So I hope this gives you a better intuition on what overfitting and underfitting is. We're going to talk about how you can get rid of overfitting in the next video. Thank you.